This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
Imagine a bot that can read the latest headline, scan on-chain activity, and place a trade on Binance, all without you touching a keyboard. That isn't science fiction anymore, it's the reality of Binance's new Agent OS, a platform that lets anyone attach a large language model to their exchange account and hand over the reins to an AI trader. In the next few minutes we'll unpack exactly how this middleware works, why it's igniting a frenzy among both retail hobbyists and professional quant teams, what hidden dangers lurk behind the glossy press releases, and how the responsibility for those risks lands squarely on the user's shoulders. We'll also explore how a decentralized inference network like ChainMind can plug the gaps left by centralized AI providers, and we'll glimpse the future where multiple AI agents collaborate like a DAO of traders. By the end you'll know not just what's possible, but what you must do to stay safe while you experiment with autonomous trading. First, let's demystify Agent OS itself. At its core, the system is a thin software layer that sits between your Binance account and a suite of powerful language models, ChatGPT for conversational analysis, Claude Code for on-the-fly script generation, and Cursor for IDE-style debugging. You begin by creating a profile for an agent, which is essentially a set of permissions and constraints. You tell the platform which tools the agent may call, you set risk limits like maximum position size or daily loss caps, and you grant it execution rights. From there, the agent can watch market data, interpret price movements, and submit orders directly to Binance's APIs. All of this is presented back to you through a dashboard that logs each decision, or through webhook callbacks that can feed into your own monitoring tools. The beauty of the design is that the heavy lifting, understanding natural language, generating code, parsing market sentiment, is outsourced to the LLMs, while Binance enforces the hard limits that keep your wallet from being blown away. Now, how does the magic happen under the hood? The architecture breaks down into 4 distinct stages. First, an input layer takes whatever you feed it, plain English commands like, buy Bitcoin if it dips 2% below today's high, JSON-formatted strategy, templates, or even snippets of Python code. That input is routed to the chosen LLM, which parses the intent and produces a structured output. Second, the processing core takes that output and calls Binance's public and private APIs to fetch real-time order book data, recent trades, and on-chain events. The model then crafts a concrete instruction set, for example, place a limit buy for 0.48 BTC at $28,300. Third, an execution engine runs those instructions inside a sandbox. The sandbox checks every parameter against the risk guardrails you defined. If the order would exceed your daily exposure limit, the engine rejects it outright. Finally, a feedback loop records the result, updates the agent's internal state, and can trigger a new prompt if the trade performed differently than expected. This loop runs in seconds, meaning the agent can continuously adapt, re-optimizing its strategy without any manual redeployment. For developers, the modularity lets you swap in a newer model, tweak the risk module, or add a custom data feed, all while the core safety net stays intact. Why are traders lining up to use AI agents on Binance? There are 3 compelling motivations that go beyond the usual hype. Speed and scalability top the list. A language model can ingest thousands of news articles, Twitter threads, and on-chain alerts in the time it takes a human to finish a cup of coffee. And it can translate that flood of information into actionable orders in milliseconds. For a market that moves on sub-second pulses, that speed advantage can be the difference between catching a breakout and watching it vanish. Second, strategy personalization becomes almost conversational. Instead of writing hundreds of lines of code, a user can say, I want to capture short-term momentum in low-cap altcoins, aiming for a 2% profit per trade, and I'm willing to risk no more than 0.5% of my portfolio on any single position. The agent then maps those high-level goals onto concrete order parameters, adjusting entry points, stop-loss levels, and position sizing automatically. Third, continuous learning promises a form of self-optimizing code. Claude Code, for instance, can rewrite portions of its own trading script after each trade, tweaking indicator thresholds or adding new filters based on recent performance. That dynamic adaptation reduces the need for a human to push updates every time market conditions shift, which is especially valuable in the volatile crypto ecosystem where yesterday's edge can disappear overnight. But here's the part most people get wrong. They assume that handing a powerful model the keys to their account automatically makes them safer, when in fact the AI inherits all the uncertainties of its training data and the market itself. Hallucinated instructions are a real danger. An LLM might generate a perfectly phrased command like, sell 10 BTC at $30,000, even if the current price is $28,800 and the order book has no liquidity at that level, leading to a failed trade or an unintended market impact. Over-optimization is another pitfall. If the model has been trained on historical price patterns, it may overfit to past cycles and crumble when a regime change, such as a sudden regulatory announcement, occurs. Liquidity blind spots can cause slippage that the agent never anticipated. In thin markets, an automated purchase of a modest token could push the price up by several percent, eroding the very profit the strategy aimed to capture. Finally, regulatory exposure looms large. Autonomous execution blurs the line between user intent and algorithmic action, raising questions about who is liable if an AI agent unintentionally manipulates the market or violates anti-money laundering rules. Binance's platform deliberately leaves the safety net at the user's discretion, meaning the onus of mitigating these risks is entirely yours. That brings us to the emerging discipline of self-governance for AI-driven finance. Think of your AI agent as a high-frequency, high-risk asset that demands the same diligence you would apply to a traditional portfolio, only amplified by the speed and opacity of machine-generated code. First, you must define explicit risk parameters, hard caps on daily loss, maximum position size, and stop-loss thresholds, and ensure the execution engine enforces them without exception. Second, regular audits of the decision logs are essential. You need to spot patterns of drift, such as an agent that increasingly favors a single token despite diversification rules. Third, version control for any custom code produced by Claude Code or Cursor is non-negotiable. Treat each script like a software release, tag it, test it, and keep the ability to roll back if a new model update introduces a subtle bug. Fourth, stay informed about model updates from OpenAI, Anthropic, or any provider you rely on. A change in the underlying LLM can alter tokenization, temperature settings, or even the way the model interprets risk language, which could cascade into unexpected trade behavior. In practice, this means you cannot set and forget. You must monitor, iterate, and intervene when the agent deviates from its intended strategy. To make those responsibilities concrete, many seasoned users have built a checklist that can be baked directly into the Agent OS dashboard. Begin with a sandbox test. Run the agent in a simulated environment for at least 48 hours using historical market data, and verify that every trade obeys your risk limits. Next, lock in hard risk guardrails. say a daily loss ceiling of 5% of account equity, and configure an automatic shutdown if that ceiling is breached. Enable an immutable audit trail that records every prompt you send, every model response, and every resulting trade, storing the logs on an on-chain ledger for tamper-proof verification. Pin the model version so that a surprise upgrade from the provider doesn't silently change behavior. Set up human-in-the-loop alerts for trades that exceed a predefined size or deviate from the expected strategy, delivering a push notification or email the moment something unusual happens. Finally, schedule periodic compliance reviews to confirm that your agent's activity respects local regulations, especially concerning leverage limits and asset eligibility. By embedding these safeguards into your workflow, you keep the AI's speed advantage while containing exposure within acceptable bounds. All of this still hinges on the fact that the inference power behind the LLMs is centralized in a handful of cloud providers. That concentration creates a single point of failure for financial applications. If an API goes down, if pricing changes, or if a provider imposes new usage restrictions, your entire trading pipeline could be disrupted. This is where ChainMind's decentralized inference network enters the picture. Instead of relying on a monolithic data center, ChainMind distributes model execution across a peer-to-peer substrate, allowing anyone with spare compute to run inference nodes in exchange for token rewards. For a Binance trader, plugging a decentralized inference layer into Agent OS could deliver lower latency because nodes can be collocated with blockchain validators and query on-chain data without the round trip to a remote cloud. Privacy improves as well. Model queries are encrypted and routed through a trustless mesh, reducing the exposure of proprietary strategies to a single corporate entity. Economic resilience follows naturally. Fees are paid directly to node operators, eliminating the risk of sudden price spikes or service bans from a centralized vendor. While Binance has not yet announced an official partnership with any decentralized AI network, the market demand for plug-and-play AI services suggests that future versions of Agent OS will support interchangeable inference providers, and ChainMind is positioned to be one of those providers. Looking farther ahead, the next generation of AI-driven trading will likely move beyond a single autonomous bot to a collaborative ecosystem of specialized agents. Picture a network where one agent excels at extracting macro sentiment from Twitter, another parses on-chain transaction graphs to detect whale movements, and a third focuses on optimal order routing across multiple exchanges. These agents could negotiate trade-offs in real time, sharing state through standardized protocols much like a decentralized autonomous organization votes on proposals. Such a multi-agent system would enable cross-exchange arbitrage, dynamic risk rebalancing, and even collective compliance checks enforced by smart contracts. To make that vision a reality, we'll need open specifications for agent communication, interoperable data formats, and sandboxed execution environments that can be audited on-chain. Regulators are beginning to experiment with sandboxes that monitor AI agents under controlled conditions, providing data that could shape future policy. As governance shifts from the individual to the collective, the responsibility model will evolve too. Risk limits will be enforced not just by a user's personal discipline, but by programmable contracts that halt any agent that threatens systemic stability. In summary, Binance's Agent OS is a watershed moment that brings powerful language models onto the trading floor, democratizing algorithmic execution for anyone who can phrase a goal in natural language. The technology delivers unprecedented speed, personalized strategy creation, and the promise of continuous learning, but it also amplifies the consequences of model hallucinations, overfitting, liquidity blind spots, and regulatory ambiguity. The onus of keeping those AI agents in check rests squarely on the trader, who must adopt rigorous risk parameters, maintain detailed audit trails, and stay vigilant about model updates. At the same time, the concentration of inference power in a few cloud giants leaves the ecosystem vulnerable, a gap that a decentralized network like ChainMind can fill with low latency, privacy-preserving,